Welcome everyone. Hope everyone's doing well. Yeah. Welcome to the last week of, the last session of the week. Hi Lawrence, how are you doing?
Yeah, I'm good, thanks.
Yeah.
Camera on.
Yeah, as usual, we'll just wait a couple minutes until everyone's in. Probably about halfway there. And a couple people have excused themselves this week. Yeah, so let's keep on going, keep on learning, keep up the engagements on the Discord chats. Really enjoying it, and yeah, I think it's a really good group of developers or future developers. Perfect. We're got another 10 people to join us, and then we'll kick it off. Yeah, so over to Lawrence. Just start whenever you feel fit.
Okay, let me share my screen. Okay, let's make a start. So today's lesson is going to be similar to yesterday. We're going to do a little bit of theory and then have half the lesson, at least for the practical side. So the chance for you to continue with the homeworks. And we also have a new homework as well. All right, so what we're going to talk about today is Web3 and in particular Web3.js. So in this context, Web3 is about how to interact with your contracts and interact with the Ethereum blockchain. So far, you've just been using something like Remix, for example, and interacting via that, and not interacting with your contracts via Remix, but not doesn't sort of show you what's happening behind the scenes. Or so what we're going to do is to start to look at that side of things, because obviously you do need some way of getting to your contracts and actually running them. And there are a number of libraries that you can use for this. What we're going to cover today is Web3.js, so this is a JavaScript library. Then next week we will look at the Ethers JS library. But there are plenty of other ones. For example, there's Web3 Pi. So lots of different languages that you can use to interact with your contracts, but they're all doing a similar thing. And they rely on something called RPC calls. And the idea behind that is that one of the nodes that are running in the Ethereum network, they can choose to accept incoming calls to the node. And if they do that, what that means is that people can connect to them via HTTP or WebSockets, and then the user can send across that connection a transaction or a batch of transactions or some commands to run on the node. So that might be submitting a transaction, the most common thing, or maybe doing a call, or it may be interrogating the node to find out some details about the network. And then the other type of connection that is possible, the IPC connection, this is where this is a connection that is local to the node itself. So it's more secure in that sense. So you're not allowing connections from outside. It's done via a pipe, really. So it's a connection from one process on the machine that's running the node to the client software, Geth, or whatever it is that you're using to run the node. And because there's no connection to the outside world, that's quite a secure way to do things. If you're running a node and you do allow RPC connections, you do allow connections from the outside world, obviously you have to be very careful about that, because you know nothing about who may connect to your machine. And when you start up the node software, you specify a flag to allow this. And one thing you can also do is you can unlock an account on that node. So you can, in theory, you can allow people access and allow people to use that account. And obviously, if you're doing this in a test environment, if you've got a local network, that may be appropriate. But if you do this on the main net, then you're going to have problems. And people have found this, that if they've started a node allowed RPC connections with an unlocked account. Within seconds, that account has been drained of any ether that it has, because there are bots out there that are scanning for RPC connections and are looking for unlocked accounts. So if you do decide to run a node and you want to open it up to allow connections, be very careful about doing that. Okay. So if you, a way of thinking about this is if you think about Remix, where we started, we had a number of environments available to us. One of them was the JavaScript VM, which was just running within the browser or within the desktop app. But then there were two other environments available. One was via injected Web3 and one was via RPC. So if you do the injected Web3, what that does is it opens up a plugin in your browser. So for example, MetaMask, and then it will pass commands to MetaMask, and MetaMask will pass those commands to various networks. And the way that MetaMask does that will depend to some extent on the network involved. If the network is also local to your machine, it will do a direct connection. If it is to one of the either mainnet or one of the known test networks, it will connect usually via Infura. So Infura is a company that provides nodes and allows people to connect and do RPC connections to those nodes. And that's the company that MetaMask uses for its connections to the test networks and to mainnet. And there have been examples where Infura has had problems and a lot of their nodes have failed, and that's people have found then that MetaMask hasn't worked so well. But in MetaMask you can configure how you connect to nodes, so you can do direct connections. And then the other option you have, if you don't use injected Web3, the RPC call. So this is where you provide a URL and a port number, and this is a direct connection to a particular node. So maybe that will be something running locally, such as Ganesh, or you could again connect to one of the test networks, and maybe that would be via Infura, or maybe if you're running your own node, you could connect via that. All right, so that sort of sets the context. Oh, one thing I should say, something that occurred to me today, was there is some trust involved here. So we've spoken about how nodes work, and when the blockchain is running and the nodes are there verifying the data that they are receiving in blocks and verifying that the transactions are correct, etc. But one thing you do when you're interacting with a blockchain is that you are trusting, if you make an RPC call, you are trusting that node to be honest with you and send back the correct information. And I don't know if there is necessarily any way that you can really be sure of that. I think it would, in theory, be possible that somebody would run a node and send back incorrect information as part of the RPC call. That it would be, you wouldn't necessarily know. Of course, you could always connect to different nodes and you would find out that way. But that just did occur to me that this is perhaps something where you do have some trust when you're doing an RPC call to the node that you're connecting to. And for that reason, it's good that there are companies like Infura that are trusted, and people use those to connect to the networks. Okay. RPC, this is a remote procedure call. And so it's a way that you can send a command or a transaction or a batch of transactions to a node on the Ethereum network. Yeah, that's 2 minutes. Okay. So we'll start looking at Web3.js. So this is a library. This was the first library that came out to interact with Ethereum. And so it's quite mature, it's quite well understood. A lot of the bugs have been ironed out. And it's composed of a number of modules that have different sort of domains, really. So the main one that we use is web3.eth. So that's for interacting with the EVM and doing transactions. there are some utils as well in the web3.utils module. So so mathematical utils, for example, converting from way to ether, that kind of thing. You can use the .NET module, also the net module, for interacting with the network itself, for finding out information about the network, so for finding out the chain ID, things like that. Now, I haven't really covered this, but when Ethereum came out, there were really three strands to Ethereum. There was I suppose what we call the EVM strand, which is what we've been concentrating on, which is the smart contract, the computation aspect of Ethereum. But then there were two other aspects as well, which are not as well known, but they have developed. One of these is the Whisper protocol, and actually I think, yeah, that's correct. The Whisper protocol, and there is a module for interacting with that. And what the Whisper protocol is a messaging service. So it allows nodes to send messages to each other. But this is done in a way that you can do this secretly. You can have private messages, and you can also have deniability about messages as well. So there's all kinds of clever sort of cryptography involved with that. It's not something I see widely used, but it is certainly there and available if you want to send messages across the Ethereum network. And then there's the Swarm network, which is decentralized storage. Now, this is an area that we will cover next week. Tom will be giving some lessons about this when we look at IPFS. And IPFS is what was really the first implementation of this. But then Ethereum did their own implementation of decentralized storage, which they called Swarm. But it came out much later than IPFS, and it was, to my mind, a little bit over-engineered. I think they tried to put too much into it. But it is now in production and is available. And you may have noticed on Remix, you get the chance when you've compiled a contract that you can upload metadata about that contract to Swarm, as well as IPFS. Okay, and then another module, the personal module. This allows you to interact with accounts, so to create accounts, for example. When we're using Web3, the first thing that we need to do is to connect to what is called a Web3 provider. So this is establishing the connection to a particular node. This is JavaScript here. So I'm assuming people can at least sort of read this. So you need to import. You need to import Web3, and then you can specify the node on the network that you want to connect to. So here we're saying we're going to connect to our local host. We're doing this via HTTP connection, and we're going to connect at port 8545. And 8545 is the standard port that you connect to when doing RPC calls. It's up to the node when it starts up. You can specify whether to use the default port or whether to use a different one if you want to do that, but 8545 is the default. You can specify WebSockets instead, so you could do WS, in which case it's 8546, I think. But yeah, if you look for documentation nodes, they will advertise which port numbers they have available. So this is connecting to your local host. Now, when you want to interact with a contract on the blockchain, there are really two pieces of information that you need as a minimum. One of them is the address of the contract on the blockchain, and hopefully you'll have become familiar with this when you deployed your contract. For example, in Remix, it would have shown you an address of the contract. And then the other piece of information you need is the ABI. And this is also you will have seen in Remix. And we talked about it a little yesterday. And this is for so that the client will know what the contract looks like, what the functions are called, what arguments they take, whether they're view functions or pure functions or normal functions, etc. So those two pieces of information are needed by the client or whatever the Web3 library to interact properly with your contract. Okay, but once you've done that, once you have those two pieces of information, then you can create a contract object effectively. This is what you're doing on the last line here. By passing in those pieces of information, you can create a contract object. Now, what I'm showing you here is the kind of the bare bones way of doing this. We saw yesterday when we were looking at Truffle, we saw artifacts being used where they handle some of this for you. But if you're not using Truffle or you don't want to use those artifacts, the sort of the simplest way, or the simplest way is to just pass in the ABI details and the contract address, and then you can create a contract object from that. And once you have that contract object, you can then interact with functions in that contract. Then right at the beginning of the course, I talked about the difference between view functions and normal functions, write functions. And this is really where, when we're using Web3, where it comes into its own. And there's the way that the call is made to the node will differ whether we're making a transaction that will write to the blockchain, that will change the state of a contract, or whether it is just reading the state. And if you remember, I explained this was because if you're just reading something from the blockchain, all you need to do is to connect to a node, and then that node can directly send you information from its local state. It will be synchronized with the rest of the network, and it can provide you with state. The difference if you're making a change to the state of a contract is that when you send that transaction into the node, then you have to wait for that transaction to be picked up and put in a block, for that block to be mined, for that block to be passed around the network, and then eventually that transaction will be run in an EVM, and the results of that transaction will alter the state of the contract. And as a result of that, the view calls don't cost gas because of that. You don't have to pay for a view call just for getting data back. So the simplest type of call you can make via RPC or via the Web3 libraries is a simple call to get some data back from about the state of a contract. So, for example, one example we've come across is in the ERC20 standard, we may want to check the balance of a particular address. And to do that, we use the balance of function in the contract. And here is an example of the code that you need to do that. So we take the my contract. This is the contract object that we created earlier. From that, we use the methods. So we're looking at the methods within that contract. Of those, we choose the balance of function. They use methods and interchangeably with functions here. We pass the address that we're interested in into this function, and then we do .call, and this shows that it is a view function that we're calling, and then you can await that. So you wait for that to complete, and then you return that. Now, I did say yesterday that there is a little difference in the way that Truffle works, and the way it interacts with contracts, and the way that Web3 interacts with contracts. So the syntax can be slightly different. So with Truffle, you can see you don't have to do this, the .call part. You can just call the balance of directly. So you could have a client, you could write this JavaScript as part of a web page or some kind of app, excuse me, and then run this code, and that would go to a node on the network, query a particular balance for a particular address, and return that value to you. And that would complete within that await, within that promise. And you don't have to worry about that being mined. It's not a transaction in that sense. So you can return values pretty much immediately. So that's an example of what it looks like. If you look at the syntax in more detail, this is what it is. So you just pick the function call or the method that you're interested in and pass in as many parameters as you may have. And then you have a number of options for that. If you want to, you can specify who this call is being made from. Now, you may not remember, but I did point out earlier on, we were talking about transactions, that this is perhaps not as secure as you might think, because although we could specify a particular address that this call is being made from, when we're doing this, we're not actually signing a transaction. So when the contract receives the call for this particular function, there will be a value in msg.sender, but that is not necessarily a true value because we're not signing a transaction. There's no transaction involved here. So it is possible for people to put in a spoof address. So just to be aware of that, when you're writing view functions, the address in message.sender might not be correct because it's not being verified by a signature. But you can add that in. It is optional. Other things as well. You can add details about gas price and if you wish to, although really this applies more to transactions, as you'll see in a moment. Then the interesting thing is the default block. So if you don't pass this in, it will just look for the latest block to take the state from. But you can ask for a different block. So it is possible to read state from earlier on in the blockchain. So if you wanted to, you could make this call and specify that you want the state at block 1000 on Ethereum, and it would return with the value for this contract, this contract state at block 1000, if that makes sense. Obviously, the contract might not exist then, but and there's some other options you can put there as well. I'm not sure what pending means in this context actually. But this is not often used, but if you want to go look back in the history, then it's available to you. And then you can also specify a callback if you want to. So instead of doing this await, you could specify a callback here which is a function in your code that would get called as this completes. Okay. So that's the read method when you're doing view functions. If you're doing a write method, if you want to update the state of the blockchain, if you're sending a transaction, then this is different. So in this case, we use the send method. It looks fairly similar. So you still use the contract object and methods and then the name of the particular function that you want to call. And then you pass in the parameters. So here we're saying we want to transfer some tokens to a receiver address, and this is the amount of tokens we want to transfer. But in this case, the from address is needed. So in the view case, it was optional. In this case, it is needed. And when the Web3 library will need access to the details of the account that controls that address. So it will need to sign the transaction that it is going to submit. And then similarly, we provide gas as well, gas details. And then one thing that will no doubt come to annoy you because it's easy to get this wrong or to get this out of sync is the nonce value. you can it, but you can supply the nonce value within the call if you wish to. And this, for example, when you're doing a transaction through MetaMask looks after this for you. But if you're doing things yourself, you may need to provide the nonce to make sure that this is being incremented correctly. So you may have to read the latest nonce for that account and supply it when you're doing the transaction. To point about the gas, you may need, because the way this has been done has changed, there are now two fields effectively for gas that you can fill in. So this is the sort of supplying the amount for the base amount of gas, the base fee, and then also supplying the amount for the tip to the miner. Now, as I said earlier, when we're doing a transaction, obviously this doesn't have an immediate response from the node in terms of what the transaction is doing, because we need to wait for that transaction to be included in a block and then actually run on an EVM. So there are a number of stages that our transaction kind of goes through when we send off an RPC call using a send. And remember, the calls are asynchronous, so we send off our call, and then we're kind of waiting for something to happen. And so this is one of the reasons I say that we're very dependent upon events, because we tend to use events to help us with this, handle this asynchronousy. But also you can, within the Web3 library, monitor certain stages once you've sent your transaction. So I've provided a link there to some the documentation, but I'll just go through what these stages are. Now, as before, you can use a callback if you want to have a separate function being there to handle this, or you can use an await. But the various stages that it goes through, there will be a sending. So this is immediately when the library sort of sends off your transaction. And then the fact that it is sent. But the default one that we see when we do a send is the transaction hash. So if you do the send if you do a send including a transaction and you wait that, what you'll get back immediately is the transaction hash. So this is the idea of the transaction. But then at that point, the transaction has gone off to the network and we're waiting for it to be mined, etc. What we really want is the next stage, which is the receipt. So if you remember, we have the transaction receipt is the results of what happens when we apply the transaction to the contract state. So we covered this in, I think, lesson 2 or 3, where we looked at what was being held in different areas in the block, and there was an area for transaction receipts. So the transaction receipts tells us the results of what happened with our transaction. So this is something that I guess we would probably really want to know. That is the stage we really would be interested in. We can wait for that, or we could even wait for events instead if we want to tell us what our transaction has done. Then other things we can also monitor. We can wait for confirmations. So what confirmation means in the blockchain sense is one block being added to the top of the block that your transaction is included in. So our transaction will be included in a block. When we have one confirmation, that means another block has been added to that and is part of the canonical chain. And you can get notified about these confirmations, up to 24 of these if you wish to do so. From a safety point of view, it is probably good practice to wait for a number of confirmations before you assume that your transaction will be part of the canonical chain. So it is possible that there could be a chain reorganization, and this is why we wait for confirmations. On Ethereum, when the block time is 15 seconds or so, you could wait for I don't know, 10 confirmations or whatever. It's really up depending on your use case. But that's waiting for that many blocks to be added to on top of the block you're interested in, so that you can be fairly confident there won't be a reorganization. But if you specify confirmation, then you'll get notified of those. And then the final thing is error. So you can specify that you want to be notified if there's an error at some stage, whether that's being rejected by the network or the transaction failing in some way. So what that looks like is this. So I've missed out some details here. Those are the dots are where your code would be, where you would deal with these various notifications. But so what you can do is you call, again, you have my contract, so that's your contract object. You're using the methods. You pick the function you're interested in, my method. You pass some parameters. You say send with some coming from some address, and you can also specify gas and the nonce, etc. in those options. And then you use this dot on and specify the things that you want to be notified about. So you can say transaction hash and then have some code here in the first set of dots that would deal with the transaction hash, the ID that you got back, and then confirmation or receipt, etc. So you can use this dot on syntax here to add your code to deal with all of these different circumstances as your transaction is being processed. Okay, I'll go through some of the questions then. So the first one, so why is a from address required for a view call? So it's not required for a view call. It's an optional item in a view call, but it can be supplied, but it may not be correct. It can be spoofed. So the syntax varies. So for example, in Truffle, you do use this. You don't have to do the dot methods thing, for example. So yeah, you can destructure it in that sense. We don't need to specify the address sender. So if you mean when you're doing a view call, yes, you don't have to specify that in Web3.js either. But there will always need to be someone who is signing the transaction. So whatever libraries you are doing, there will always be an address that is being sent from, that someone that is signing that transaction. So it does. It is needed, definitely. Can you clarify the contract execution? The transactions, when they are submitted to a node, and it's up to the node how they want to handle them. They will do some verification. They may try to execute them. They may execute them themselves if they want to, but at that stage, they would typically be in the node's mempool. And then some node on the network will pick up that transaction and put it in a block and mine that block and then send that block out. And then that block will be passed around to all the nodes in the network. And then every node will receive that block. And at that point, it will then go through the transactions in the order that has been chosen by the miner. And it will go through the transactions that have been chosen by the miner and execute them and update their local state according to the transactions that are in the block. So although it will be possible for them to execute transactions before they are mined, they would really have to ignore that, because when they get the block, that transaction might not be in the block, or it might be the order of transactions may mean that that transaction would fail. So really, you should think of it, the transactions are only being executed, and the function calls in your contract only being executed when they are in a block, and when that block is received by nodes running the EVM. Now, so that's how the simplest way of interacting with our contract and calling functions within our contract. And we'll see when we look at ethers that it is slightly different, but fundamentally the same kind of idea behind it. Then, as I say, the way that we react to what is happening in our contract, we can do that from the transaction as well and from the transaction receipt. But another way to react to our contract is via events. Now, I said it's good practice to have lots of events in your contract because we want to know what your contract is doing and we want to understand what transactions are happening. So it's useful for us to be able to monitor events, and Web3 library allows us to do that. And there are, 3 ways that you can get information, if you can monitor events. So one of them is this, the get past events method that you can see here. So again, working with a contract object, you can call get past events and pass in the event name. And then that will come back, will send you back all of the events that of that particular name for that particular contract. Now, just to be aware that if you do this with an event like transfer, that could well end up being a lot of events on any given contract. So this may take quite a long time to return because you may end up having a lot of events. But that is possible. So you could end up getting all of the events that are emitted, and well, we'll see later what you get back when you get the event. But the event is effectively a log, and it's logging certain pieces of information. And you can use options to make this a little bit more feasible. So as you can see here, you can put in filters for various values. So in the transfer event, there is a field called value, and you can filter on that so that you get back only the events of let's say are 1000 or 1200. Then you can also filter effectively on the blocks that you're going to search for the events. So this would search for everything, but you could narrow that down. So that's useful if you're looking more for a historic view of events. You can also do it a sort of a more immediate view of events by what you do is you do my contract and events. So you're kind of looking at the events collection. You specify the event's name. You can pass in options again. And then you have this syntax once again, like we had with the send, where you have .on and various things. So the one you'd probably want to monitor, to use, is this data one. So this will come back every time that an event is of that name has been emitted, and will send you the data for that. Changed means if there's something about that, if that event has been removed for some reason. So that's more of a kind of a meta event, I suppose. So you probably wouldn't want to be monitoring that so much. Error is just useful if, when you're setting up this monitoring, if there's some error, you would obviously need to know about that. It's really an error within the monitoring itself. And then connected, it just fires once to say that this has been set up correctly, that you are monitoring correctly for that. Okay, let me just go through some of these questions, although they are Tom's answering them, so that's okay. So yeah, I said that there are 3 different ways of looking at the monitoring the events. So the first one was the get past events, but this is a separate thing. So you're not using get past events here. You're using the events collection here, and getting them as they happen. Yeah. And the type of information that you get back is this. I think it's probably what you would expect. So when an event is emitted, there is some default information that will provide. So it will tell you the address. So so the contract that this is being emitted from, the block number, the transaction that caused this event, and I think this is the index within the block. Then details about the block, details about the event within the events collection in the block. What you're really interested in is these second in the return values in the named ones here. So these are probably what you're going to take out of the object. So when you create an event, you specify, or you can specify, named fields in that event, and those names are then used and returned along with the items that you get back. So effectively the names are the keys, and then the item, and then we have the values for those keys. So for a transfer event, we're saying who the coins are, the tokens are being transferred from, who they are being transferred to, and then the number of tokens that are being transferred. So that's the value amount. And you do get other bits of information, but typically it would be those fields there that you would be interested in. And obviously those are going to be quite specific to the specific event that you are monitoring. But then you've already decided what that event is going to be, because from the events collection, you've picked that particular event. So you will know what you're expecting back in terms of the fields. Okay. And then the other method that you can use is the subscribe method to subscribe to all events, potentially from a particular address, but you can then specify in the options which you can narrow that down and specify particular ones. So this is kind of a more dynamic way of specifying what you're subscribing to. But similarly, the things that you get back, you have the same conditions that you're reacting to there. Yeah, and you get back similar data. Okay. So that's how you listen to events. How am I doing for time? I'm okay. And then, yeah, if you want to interact with accounts, you can. There's an accounts method for that, and you can get list of accounts, etc. One useful method that you have is estimate gas. So this is a way that you can get an estimate of how much gas will be used by your transaction before you actually submit the transaction to the blockchain, and it's done by effectively sort of simulating that transaction running and then working out how much gas that would use. Some utility functions there, and details about block numbers, etc. So that's some of the main libraries or some of the main modules in Web3. The providers, I started off talking about HTTP. Also, you can use WebSockets. And if you want to use the IPC provider, you can do that. As you can see here, the address that it uses is effectively a directory on the machine. It kind of works out to be a pipe on sort of Unix machines, or on Windows is a little bit different. Yeah, for example, with Infura, you can use this type of syntax to specify an Infura node. You need to sign up to Infura and specify your ID for that. It's a free, you can sign up for free, but there are limits to the free version of Infura, but it's pretty good, so it's worth having an account. Or there's also Alchemy as well you can sign up for. And then you can create wallets. So if you want to, when you're signing transactions or submitting transactions and signing them, you will need that to come from a wallet. And you can set this up as part of the provider in this way. So this is a sort of part of Truffle, and you can specify this in the Truffle config. If you do set this up and do set up a wallet and use a mnemonic for the wallet to be initialized, please be careful. Don't put this in. Don't leave the mnemonic in your code, and check this into GitHub. Again, people are monitoring for that sort of thing, and if you do that, your wallet will lose its funds. So if you're going to do this and have a mnemonic, make sure you go to have an environment variable perhaps, or a .env file, something like that, that is not going to be not going to be checked in. And so you'll keep that secret. Yeah, if you do that, then you can use web3.getAccounts and then use that to sign the transactions. So there's some details about that there. If you're interested in that, this is kind of, I guess, more applicable to when you're using Truffle for that. And again, otherwise, you can add wallets in this way, specifying a private key and address. But again, be careful if you're doing this, specifying private keys in code. Be very careful about doing that. Yeah, and I just want to show you an example of some code that uses Web3. If you want to try this out, you can use the Truffle box called Webpack. So I showed you this on yesterday when we were looking at Truffle, that these various boxes that you can use. I've put the code in this gist as well. So I just wanted to show you what it looks like if you're writing some code to interact with contracts. And really, you start at the bottom here. Now, I do need to check this code because this has, the way that MetaMask interacts has changed. So I will check this after the lesson. And if this is out of date, I'll update this gist. But this shows you the general idea that it is setting up the Web3 provider. So this could be using MetaMask, in which case, if you're doing this, MetaMask would pop up at this point and you'd use your MetaMask wallet. If it can't find MetaMask, then it will look for a node. So here I've said, well, instead of MetaMask, we'll use a HTTP provider and we'll go to our local machine for that. So that's kind of an initialization for this piece of code to set up the Web3 provider. And then what this code is doing, this is part of Truffle, so we can use artifacts, and this MetaCoin is a simple token contract, so it's just about sending tokens. But once we have our Web3 object, we can use that to get the network ID, so we can get information about the network. And after we've done that, we can get information about the contract itself. So because we're using artifacts, we have the information, we have the ABI and the contract address. If you weren't using artifacts, if you're not using Truffle or Hardhat, then you could specify these separately in some way. But once you have that, that means you can then set up a handle to your contract object. So in this case, we've called it meta. We can get the accounts that are available to us. And this is assuming there's an array of accounts, and we're going to default to using the first one of those. And then we call this refresh balance function, which goes in, chooses the get balance function from our methods, and then uses that to call the get balance function within our contract for a particular address, which will give us back a balance. And then that gets displayed on the HTML page that this is associated with. And then so that's a nice view function and call functionality from Web3. Then also there's the send coin function, which allows us to send a transaction. So here we're reading the amount of tokens that we want to send from the web page. We get the address that we're going to send them to from there. We set up some sort of status for our web page. Then we pick the particular function we're interested in, called send coin, and then we call it, passing in the receiver and the amount, and saying who this transaction is being sent from. And now this kind of cheats in a way. It's the way this does this is I don't think best practice, because what this is doing is it's awaiting that, so it effectively gets the transaction hash, although it doesn't keep it, it just throws it away. And then it calls the refresh balance again. So it's assuming that in the time it takes to do the send coin and setting the status, that transaction will have happened and have been mined and will have run. And then it recalls the refresh balance, so it goes away and gets the state. This wouldn't necessarily work. It could be the case that by the time when you call refresh balance, you call this too soon and the transaction hasn't run. So it would be better to wait for an event here, or in the send coin to wait for the transaction receipt. But I think when they wrote this, they were thinking of a simple, so maybe a local blockchain that happens very quickly, where the mining happens very quickly, so they weren't so worried about that. Okay, so that's just some example code that you may want to look at to get an idea of how Web3 works. Now, that's all I wanted to cover about Web3. We will also then cover ethers next week. It's up to you which one you want to use. They're both fine. It's really down to, I guess, which environment you want to use, whether you're going to go with Truffle or with Hardhat. But yeah, we'll cover ethers next week. Now, I'll just quickly go through the homework number 4 for the answer. So I've posted this on Discord. Also, there's a gist with this code if you want to copy paste it. It's a bit easier. I don't know why it's come out quite like this, but anyway, I think it's very straightforward. We have our total supply. We've declared that variable public, so it creates a function for us to get that. Similarly, we have a public function for our balances. And then we have a struct for payments, which we're going to expand on this, and the other homeworks have expanded on that as well. The only owner modifier, because we want to restrict who can call some of our functions, and a couple of events. We have our constructor setting up the total supply initially and setting up the owner and giving all of the total supply to the owner initially. And then some functions, the update total supply, we restrict that to the owner, and this increases the supply by 1,000 at a time and sends out an event to say that has happened. And then a transfer function for our tokens, similar to the ones you'll see in the ERC20 implementations, where we check the balance of the person calling the transfer method to make sure they have sufficient tokens. If they do, we then decrement their balance, increment the recipient's balance, and emit an event for that. And then something that people do get stuck on sometimes, this get payments method. So if you for the the payments mapping, if you make this public, what it will do is it will give you a method, but what it will try to do is to not only take the address of the user, it will also try to take the index of the array that we get back as well. So which is sort of going down to the lowest level that it possibly can, but it's not exactly what we want. So instead, we can write our own function here where we want to return an array rather than just one item for the array. So we pass in the user and then it returns the array from that particular mapping that applies to that particular user. So I hope that's straightforward. So please, have a look at, check that against what you've done in homework 4, and discuss in your groups as well. But also you can ask questions on Slido if you want to. Okay. Yeah. So the question about the returns the memory keyword here, and if you try this out, if you try it out without the keyword, you'll see that the compiler will ask you that. Yeah, it'll ask you. It wants to know where, what area that is going to be used. Okay, so that's that. Then the homework from today. So for you to do over the weekend. So what I'd like you to do is to using either Truffle or Hardhat, whichever one you would prefer, create a project for your Volcano coin, and obviously we'll be using this project for further contracts throughout the course, and add your contract to that project, and then write some unit tests for your contract. And the tests I want you to write should be to test that the total supply has been correctly set up. So it's set up to be 10,000 initially. That increasing this total supply works correctly, and that it goes up in by 1,000 tokens. So that's the function that you have to do that. And that function that you do to increase the supply can only be called by the owner of the contract. So some very straightforward tests, but I would like you to try those out to get yourself used to writing unit tests. If you need help with the syntax for that, there are plenty of examples. So I've given you some links there to guide you. If you look in the Gitpod workspace we've supplied, you will also see in the Hardhat example, you will see an example of a tests for a different contract. In the Truffle example, we've got part of a test. We haven't filled in the function body, so you'll have to think about how you want to do that. But in either case, you can look at the documentation to work out the syntax for writing the unit tests, and it is quite straightforward. I gave you some examples yesterday as well. I don't think you'll have any any trouble with that. So you're saying about the emit. Okay, so so for this particular homework, for homework 4, we just were doing the transfer and emitting that we had that. So homework 5, we take that the step further to then put the details into the array. So we will come on to that in the next homework. So that's correct. Okay, so how are we doing for time? We've got another half hour, so please carry on with the homeworks. Let me know how far you've got. So so most people have got to I've done homework 4, and I've given you the answer now anyway. So a few people have got up to 6. So please carry on with those, and we'll answer any questions that you have on Slido as well. Okay, thanks everyone.
Perfect. Thanks, Lawrence. We're just going to sit here. We all done, I presume?
I'm happy to stay here and answer further questions for people to work on as they work on the homeworks. Yeah.
Okay, perfect. Yeah, let's just do that and then call it when you want to call it.
Sure. The question about the payments array. So if you're returning an array, then you can just iterate through that in your client code or however you're calling your function. But it is also possible to return tuples as well. But look at the function signature. That will tell you exactly what it is that you're returning. That you have to specify the data type. So yeah. That okay? So, and the question about the unlocked account, yeah. So if you unlock an account on the RPC node, what happens is that when you can send a transaction, and then that transaction will use can use that account to run the transaction, and will be as if that account has signed the transaction. Test for the payments array. So generally speaking, when you have a mapping, yeah, this is a general problem that when you have a mapping, if you look for a particular item in a mapping, you will always get back a result, but you don't know whether you might not understand what that result means, because if we talk about, say, a mapping between an address and an integer, then we could get back the value 0 if we put in an address. And that could mean either that 0 is the correct value for that particular address, or it could mean that there is no value for that address. It will either give you back default value for that data type. So one way around that, when you're returning things from a mapping, is to have an extra field. So perhaps you have a struct which has an extra field, and one of the fields within that structure is something to say that this actually exists, and is not just returning the default data type. Yeah. So when you do a return from a function, you have to say the type of the data that you're returning. Yeah. Okay. Yeah, just locally. Yeah. So the question about the return and the storage location. So if you have to specify it when you say the data type is a reference data type, so not one of the simple ones. Yeah. ZKP use case. I mean, you can, if you're doing that in contracts, it's easiest to use something like Socrates. I'm not sure for a good example. Yeah, I'll have to think about that. A lot of the examples, a lot of where the work is being done with zero knowledge proofs and contracts is around scalability and layer 2, but that's it's not a simple thing. So if you want a simple one, I would say, yeah, have a look at the Socrates project, and you can do simple things there. So the Slido link is always going to be the same for this bootcamp, and then the questions and the answers are in the archive tab. So if you click on archive, you should be able to see that, but we can also copy those out and put them in a document as well. Yeah, I'm presuming you can see the archive tab. If not, then let me know. Okay, maybe the archive tab is just something sort of an administrator thing. Okay, so we'll put them in. Yeah, we can put them in a document for you, so you can go back and have a look at the questions. Yeah. We will talk about the graph as a project, though I don't think we'll be able to go into the like the GraphQL, etc. But we will talk about it and go through sort of how it works and what the various parts to it are. Yeah. The question about the lightweight nodes. So the nodes can talk to each other and ask each other for details of state. So they can talk to archive nodes and ask for state. Also, some nodes are lighter in that they do snapshots as well. So they may not hold all of the history of the blockchain, but they will have a snapshot, and then from that point on, they will have sort of worked out their own state. So it really depends how the node has been set up, how it's running. But yeah, there are a number of ways it could do that. So it could be that it does it itself, or it could be that it's asking other nodes for particular details. It's not stored, so the bytecode is kept, but that is, which is part of the account, but that's kind of more than the code hash is just a hash of that. Yeah. So it's the bytecode itself that is kept. In fact, yeah, I'm not sure that, yeah, so the bytecode will be stored because that's part of a transaction. So the bytecode will have been sent in a transaction and will be able to be stored, but that's not sort of kept in the blocks. It's just that we just need the code hash to know that there is code there. And that's correct. It's the same way with other state, yeah. So the question about the number of contracts, I would say that the bulk of, it does depend really, but the bulk of DApp work probably is the logic around it, because doing the logic in the contract is expensive. So yeah, I would say that there's more in the DApp. But the limit to the number of contracts is the only limit is the number of addresses. So there's not. Yeah, so I think what you're getting at is that, yeah, it's good practice for people to use libraries, which is true. So it would be better to have fewer contracts, and for those contracts to interact with each other more, and use libraries rather than repeating the same code again and again. Yeah. So about the homework 4, yeah. So the adding to the payments mapping is in homework 5. So we'll cover that in homework 5. Yeah. So yeah, I agree that we probably could do with we probably could use fewer contracts, but particularly in DeFi projects, there's quite a lot. There's quite a lot of functionality. I mean, a lot more functionality is done within the contract itself. So there's still plenty happening within contracts, and I think there will always be some Solidity work expected. But in a particular project, it may be that the Solidity work would be 10% of the whole thing, and the 90% will be done in the DApp instead. Yeah, I think the developers will, I guess, have roles of contract developers, Solidity developers, and then but they will probably also need the Web3 or the Ethers experience as well. And whether then you have different developers who are more experienced in the front end, back end, it depends on the project and the team. Yeah.
Sorry, I think Lawrence's Wi-Fi is struggling there, but Lawrence, are you?
I think you often get the case where it depends on the size of the team. So you may have the same developers doing the contracts on the front end, or it may be that you have someone who is a specialist on UI or UX. Sorry. I think it would depend on the size of the team. So you may have the role of doing the front end and the Solidity as well, but it also may be the case that you have some separate developer to do the UI UX. It is more logic, I suppose, but then that is in the context of decentralized app. So that's probably also something that is quite new. So then traditional developers will probably not know how to design an app for decentralization. The idea of sign a transaction without a fee and then paying for it or having someone else pay for it, we will cover in later lessons. There are methods and functionality around that. Yeah. Around wallets. Yeah, I don't know about that. I should mention actually the MetaMask do have this notion of, I think they're called snaps, which are little applications that are kind of extensions into MetaMask. So that may be, it depends which bit of the wallet you're interested in, but that may be something that will be useful for you. We won't really go into anything beyond tokenomics. I mean, I think I talked a little bit about crypto economics, but yeah, I don't know tokenomics well enough. It's not something we can really go into in this course, I'm afraid. Yeah, I'm afraid I don't have any resources about monetization strategies. There are people who specialize in sort of tokenomics and understand that area better, but yeah, I don't really know that area, I'm afraid. List of last token owners. Yeah, so you can see for ERC20 tokens, you can look at the transfer events and see who had tokens transferred to them. Obviously, that really ties into your question about the graph earlier. That's what the graph really, where it comes into its own, because that will sort of give you all of that information in a nice database. But yeah, to do it in Web3, then yeah, you can use events for that. Okay, so I think our time is up for today. Thank you, everybody. Enjoy the homework, and I'll speak to you on Monday.
Lovely. Thanks, Lawrence. Really appreciate it. Yeah, thanks everyone in the bootcamp. Have a lovely weekend. See you later.